what are equivalent expressions? Think about this question during the lesson. The Student Council has spent $337.50 on supplies needed to sponsor a dance concert fundraiser. 3 council members wrote these expressions to represent the total amount raised for T tickets sold. 6 75/100ths times T minus 337 50/100ths. 6 75/100ths times the quantity T minus 50, and negative 337 50/100ths plus 6 75/100ths times T. Can they all be correct? How can you use the properties of operations to determine whether the expressions are equivalent? Let's begin by verifying that the first expression represents the amount raised for T tickets sold. Does this expression represent the amount raised from ticket sales? The expression subtracts the cost of supplies, $337.50, from the total amount raised. The expression does represent the amount raised from ticket sales. You can use the properties of operations to write expressions that are equivalent to other expressions. What property can you use to remove the parentheses from this expression?
Select your answer.
Use the distributive property to remove the parentheses. Multiply each term inside the parentheses by 6 75/100ths. 6 75/100ths times T minus 6 75/100ths times 50, which simplifies to 6 75/100ths times T minus 337 50/100ths. 6 75/100ths times the quantity T minus 50, and 6 75/100ths times T minus 337 50/100ths are equivalent expressions. What property of operations can you use to rewrite negative 337 50/100ths plus 6 75/100ths times T so that you can compare it to the other two expressions? The commutative property, which says A plus B is equal to B plus A, allows us to change the order of terms. Negative 337 50/100ths plus 6 75/100ths times T is equal to 6 75/100ths times T plus negative 337 50/100ths. And adding a negative number is the same as subtracting its opposite. 6 75/100ths times T minus 337 50/100ths, 6 75/100ths times the quantity T minus 50, and negative 337 50/100ths plus 6 75/100ths times T are all equivalent expressions. The council members wrote equivalent expressions. They are all correct. Now you've seen how properties of operations can help you figure out whether expressions are equivalent.
Nancy wrote the expression 1/2 times x minus 12 to represent the relationship in a table of values. Use properties of operations to write two equivalent expressions.
If we use the properties of operations to help us, as we can see in the first example of an expression we have here, you have those parentheses around some parts of the expression and a number attached to that parentheses that typically indicates you are using the distributive property. So we think to ourselves, 1/2 times x equals 1/2 times x, because we use it this way, and then 1/2 times what number is going to be equal to 12. So again, as I showed you in 4-1, when you are multiplying times a fraction, you are actually dividing. So 12 divided by, and you divide by the denominator. So 12 divided by 2 will give me 6. So the answer there would be 6. And that is one way of writing an equivalent expression. The second is using the commutative property, which means we can switch the order of the numbers. So we have, let me erase this. We have 1/2 times x minus 6 at the top. And then we have here for the second one, 1/2 times x behind the plus sign. And then we'll just put the -6 in the front. And that's the commutative property of switching those orders. And then that's it. We're not solving this because they only want us to write 2 equivalent expressions.
Write equivalent expressions by combining like terms. Part A. -5 and 25/100ths times x plus 2 and 75/100ths times y plus 3 and 5/10ths times x. To begin, write the original expression. Next, use the commutative property to rearrange the expression so that like terms are together. Use the distributive property to combine like terms. -5 and 25/100ths times x plus 3 and 5/10ths times x is equal to the quantity -5 and 25/100ths plus 3 and 5/10ths times x. The last step is to simplify -5 and 25/100ths plus 3 and 5/10ths, which is equal to -1 and 75/100ths. Use patterns and structure. How can you check whether the expressions are equivalent? One way to check your answer is to review each step of your work. Another strategy is to choose sample values for the variables, and then evaluate the expressions. If the expressions are equivalent, then their values will always be equal. Now write an equivalent expression for Part B. 1/3 x plus the quantity 1/6 x plus y. Write the original expression. Next, use the associative property to change the order of the addition. Find the common denominator for the two fractions. Write 1/3 as 2/6. Use the distributive property to combine like terms. The expression is 3/6 x plus y. Notice that the original expression has 3 terms, and it simplifies to an equivalent expression with 2 terms.
Use properties of operations to write 2 expressions that are equivalent to 3/4 times n plus the quantity 8 plus 1/3 times z.
So we're going to write 2 expressions using the properties of operations. The first property of operations we can use is the associative property, where you just change the order of the numbers. So you can do 8 plus 1/3 times z in parentheses plus 3/4 times n. So that's the flip of the original expression. So with associative property, again, you're just changing the order. The other order, properties of operations we can use is taking we can just switch, the order of the numbers, which would be the commutative property. So we can take 8 plus 3/4 n plus 1/3 z. So just putting it in a different order, putting parentheses around those two, is the associative property. The commutative property. So we still have an equivalent expression.
Which of the expressions below are equivalent to negative 2/3 times x minus 2?
Let's try dropping the tiles. Negative 2/3 times x plus negative 2 is equivalent. It stays. Up, that one doesn't stay. 2 minus 2/3 times x. So that will go under not equivalent. And it's not equivalent because my 2 here in the original expression is negative. The 2 here is not. So that automatically makes it not equivalent. Let's see about this one. There we go. And so it is negative x plus parentheses 1/3 times x plus negative 2 end parentheses. So they show us here negative 2/3 times x plus negative 2. That's the original expression, and it says to subtract the additive inverse. So the 2 minus 2/3 x is equal to negative 2/3 x plus 2. That's using the commutative property, which means you could change the order. And then the expression is not equivalent to negative 2/3 times x minus 2. That's this one here. And the final one, negative x plus 1/3 x plus negative 2 in parentheses. They use the associative property, so that means you can change the grouping of the numbers. So instead of the parentheses being around these two numbers, they switch them to be around the negative x and 1/3 times x. And then if you were to simplify that expression, let me write it, the negative x and adding the 1/3 x, that's essentially negative 1, because you know that if you have a variable with no number written there, you know there's an invisible 1 in front of it. So negative 1, plus 1/3, and let me show you. That'll be negative 1 over 1 as a fraction, right? Because we're adding. And you can definitely use a calculator. I'm just showing you it without it. And then when you're adding fractions, they have to have the same denominator. So then I need to multiply 1 times 3 to give me 3 as a denominator here, or I have to do the same thing to the top, and that becomes 3 over 3. Okay, it's 1 whole, so 3 over 3 is also 1 whole. And then add that to 1/3. I forgot that's negative there. And then we just add. Our denominator stays the same. So we have negative 3 plus 1 will give me negative 2. So now we have negative 2/3 x, after we add that together, plus the negative 2 that is there, and that is using the associative property. So that expression is also equivalent to the original expression. Let's move on to the try it.
Write two expressions that are equivalent to negative 5/4 times x minus 3/4.
Let's use, the associative property. Actually, let's use the commutative property. The commutative property means that we just change the order of the number. So we can have negative 3/4 minus 5/4 times x. So that would be one equivalent expression. Another equivalent expression we can do is using the distributive property. We could take out, let's see, when you're working backwards to go from something like this to a problem that looks like this, where you have the number on the outside and then the numbers on the inside, when you're going from here to here, you have to think of common factor between those two numbers on the inside of the parentheses. That's the only way that using the distributive property as an equivalent expression will work. So a common factor of 5/4 and 3/4 would actually be 1/4. So if I were to take 1/4, and I can make it a negative because both of my fractions are negative, put that on the outside of my parentheses, keep my plus sign in the middle here, and so negative 1/4 times what will give me 5/4, and then that would be 5, and we have to keep our variable x, so 5 times x, and then negative 1/4 times what would give me 3/4, and that would be 3. And then now we have another equivalent expression using the distributive property.